Alright, so now we are going to switch gears to section 10.3, continuity, and we're going to start with problem number 3. So problems 1 through 6 prompt us to use the definition of continuity to show that the given function is continuous at the indicated point. So remember, there's 3 conditions that must be met in the definition of continuity. One is that at a given point, the function must be able to be evaluated at that point. So the function we're looking at here is g of x equals the square root of 2 minus 3x. And we're looking at the point where x equals 0. So the first question is, can the function be evaluated at f of a? And so we need to see if a is in the domain of this function. So 2 minus 3x has to be greater than or equal to 0. This is how we're going to find the domain of this function, right? So then we've got negative 3x is greater than or equal to, we subtract 2 from both sides. And then we divide both sides by negative 3. We have an inequality here, so that's going to switch the direction of the inequality. So we're going to have x is less than or equal to 2/3. So as long as x is less than or equal to 2/3, then the function can be evaluated at those values. So 0 is less than or equal to 2/3, so then f of a does exist. Okay, so that's the first condition, and it's been met. The second condition is that the limit of the function as x approaches the value we're looking at must exist. So going back 1,000 years to, a few minutes ago when you were likely doing the limits chapters, we need to evaluate this function and evaluate the limit of this function, the limit as x approaches 0 of the square root of 2 minus 3x. And so just looking at the limit as x approaches 0 from the negative direction, so the numbers are going to be less than 0, and those fall within the domain of the function, so the limit will exist. And then the limit as x approaches 0 from the positive direction, well, so remember, we're approaching 0, so we're getting infinitely close to 0, and that's going to be numbers from the positive direction. They're going to be less than 2/3. So the limit does exist as we're approaching 0 from the positive direction as well, and so the limit does exist. And then finally, the third condition is that the limit of the function as x approaches 0 of 2 minus 3x must equal the function evaluated at 0, which is the square root of 2 minus 3 times 0, which equals the square root of 2. And so the limit of x as x approaches 0 of square root of 2 minus 3x equals the square root of 2 minus 3, 0. So we can just plug in 0 for x. And thus, we're going to get the limit equal to the square root of 2, which is equal to the function evaluated at 0 as well. And so all 3 conditions are met. And so the function is continuous at x equals 0.